Hi, in this video, let us try to understand about decision tree model. Let me first start by giving an intuition about what decision tree model is all about. After that, we will look into more details. So let's say I have a data set which is like this. I have age, country and a y variable which is my target variable or which is a categorical variable over here. And if I want to predict y by looking at age and country, and if I try to make a random guess that, let's say if I see a record like this, and if I try to make a random guess that okay, this is either class 1 or class 0, then in that case, can you guess what is my probability of success? If you have guessed it right, it is exactly 50 percentage, because I have here 10 records. Of these 10 records, 2, 3, 4, 5, 5 belong to class 1 and 5 belong to class 0. So overall, the class distribution is equal. That is, the probability of class 1 is 5 by 10 and probability of class 0 is also 5 by 10, which means I have the highest uncertainty over here. I have the highest uncertainty over here because I have equal number of examples for class 0 and for class 1, which are 5 for class 1 and 5 for class 0. So if I predict that given a random record, either a new record or the existing record, if I predict that either it will be class 1 or it will be class 0, my success probability is exactly 50 percentage. And I have two classes, which means the uncertainty is the highest, which is, in other words, it is exactly equal to 100%. I am 100% uncertain because the probabilities are equal for both the classes. But what if I look at a particular subset of the data rather than looking at the entire data? What if I look at only one particular subset? Say, for example, I look at all the records which belong to the country India. So how many records do I have? I have these two records which belong to India, and then these two records. Totally four records are there which belong to country India. Of these four records, all of them over here belong to class 1. All of them belong to class 1 and 0 records belong to class 0, which means I have 100% accuracy whenever I know that the data belongs to the country India. My probability has certainly increased to exactly 1 because all of the records I have, all of them belong to class 1. So in future, if I get a record and let's say that record belongs to country India, what I would do is I would just make the prediction that it will belong to class 1, because based on the previous history, in all the situations where the country was India, the class belongs to class 1. So in that case, I will take a guess and then make a prediction that when a new record comes and it belongs to country India, I will make the prediction that this record will belong to class 1 based on the previous probabilities. And even let's say I want to predict for this record from the trained data, and in this record I will straight away predict that this record belongs to class 1. And that is a correct prediction. So this is exactly what decision tree model will try to do. So over here I would have 0% uncertain. That's because all records belong to class 1. That is, the probability or accuracy is 100 percentage in this case. Similarly, let us look at a data set, a subset where the country belongs to UK. For UK, I have got two records. This is the first one and this is the second one. And I also have a third record here. And okay, 1, 2, 3. So in total, there are 3 records. And out of these 3 records, okay, let me make this as class. Let us start with class USA. In case of class USA, in case of the country being USA, 1, 2, 3. I have got 3 records and all of them belong to 0, class 0. So let me make this also USA. Okay, so total I have 4 records, 1, 2 and 3 and 4, total 4, and all the 4 belong to class 0 over here. So over here also I have got 0% uncertainty and 100% accuracy, obviously. And in case of UK, which is this record and also this record, I have one record belong to class 1 and one record belong to class 0, and hence I have two records, total 2 records. One record belong to class 1, one record belong to class 0. So over here, if I make a random guess that, let's say if I get a data set that belongs to UK, and if I guess that it belongs to class 1, what is my probability of success? So over here, according to this, it will be exactly 50%, because I have equal number of records in class 1 and class 0. So it will be 50%. Uncertainty, 50% accuracy, which implies 100% uncertainty. Okay. But if you observe here, initially when I was doing the classification by looking at the entire data, I observed that in my entire data I have 50% of the records belong to class 1, 50% of the records belong to class 0. So accuracy is 50%. If I just predict randomly that a record belongs to class 1 or class 0, I have a 50% accuracy. But if I predict by looking at a subset of the data, let us say one subset belongs to country India, another subset belongs to country US, another subset belongs to country UK. So I have observed that in case of India and USA, I have 100% accuracy. In case of UK, I have 50% accuracy. So overall, when I find the weighted average of all the accuracies, it will be 90% accuracy. I'll be getting 90% accuracy. So from 50% accuracy, I have jumped to 90% accuracy. I've jumped to 90% accuracy by looking at subsets and doing the prediction. So this is all what a decision tree model will try to do. A decision tree model will try to divide the data into subsets like this. The data got divided on the basis of country feature over here. Whenever country was India, that was one subset, and country was US, another subset, and UK another subset. So the decision tree model will try to divide the data into many subsets in the pursuit of increasing the accuracy. From the previous one. Here it was 50%, and now it went to 100% here and 100% here and 50 here. So overall 90% across all the records. All right. So let us take one more example and try to understand this. So let us say I have these features: country, age, gender, and finally the target variable, y variable. So initially when I look at my data set, the entire data set, so okay, can you tell me how many records belong to class 0 and class 1? It is exactly 5 records belong to class 1 and 5 records belong to class 0. So thereby I can write 100% uncertainty, 50% accuracy is what I have. So let's say I can divide my data into some subsets. I can divide my data into a few subsets like this. Okay. So what can be the criteria? So can you take a guess and tell me what can be the criterias in which I can divide my data into different subsets? So one criteria can be that I could divide my data, let's say, based on country. So over here, I will have all the records that belong to USA. Okay, I have only 2 countries here, so I'll only have 2 subsets. One subset belongs to country USA, another subset belongs to country UK. And I could have also divided the data based on gender. That is, all the records that belong to male will be in one subset, and all the records belong to female will be in another subset. Maybe I could have divided my data on the basis of age as well, on the basis of age column. So maybe it could be something like this, where age is less than 23 and age is greater than 23. I'll have some records here and I'll have some records here. So basically I have three options on which I can divide my original data, that is the entire data, into subsets. The first option is I can divide my data based on the country age, based on the feature called country. And second option is I can divide based on the age, and third option is I can divide based on gender. So let us have a look at what happens in each situation. So if I divide my data on the basis of country, how many records do I have that belong to USA? I have 1, 2, 3, 4, 5, 6 records. Out of 6 records, okay, let me write this down. I have got 6 records. And here I have 4 records. In fact, let me put this inside. And 1, 2, 3. All right, so I have 0 is to 1. 3 records belong to class 0 and 3 records belong to class 1. Okay, so initially I had 50% accuracy at this point. So what is the accuracy at this point? So right now the situation is that I am looking at only these particular records, 1, 2, 3, 4, 5. Okay, these ones and these ones. So among these records, the number of records belong to class 0 are 3 and class 1 are 3, which is again equally distributed, so equal probability, which means if I make a prediction that in these 6 records, if I make a prediction that all records belong to class 1, all of the records belong to class 1, what is my accuracy? It's exactly 50%, because I am correct 3 of the times, I am wrong 3 of the times. So if I make a prediction that all these 6 records belong to class 0, again my accuracy is 50%. So I am getting an accuracy of 50% over here, which means no jump in the accuracy from here to here. Okay, let's see what happens in case of UK. Maybe in UK I will get a better accuracy. Let's see that. Let's see how many records I have in UK. I have 4 records, and let's see all the records. Class 0, class 1, class 0, class 1. So total, again, the distribution turns out to be like this. 2 records in class 0 and 2 records in class 1. So overall here also 50% accuracy. So if I take the weighted average of all of these, both the accuracies, I will again end up getting 50%, which means the initial accuracy was 50% when I'm looking at the entire data and predicting, and when I'm looking at the subset and predicting, then also the accuracy is only 50%, which means there is no jump in the accuracy, which means decision tree model will not consider this as an ideal criteria to split the data into subsets. Okay, fine. Let us look at what happens if I divide my data based on gender. So let's see how many records I have that belong to male and female. So I have 3 records here, 4, 5 records belong to male, and all of the 5 records are belonging to class 0. So over here I will write here 5 rows. So this also will naturally be 5 rows, and 0 is to 1, 5 is to 0. All 5 records belong to class 0. And how many records belong, what about the female gender subset? So both are class 1. Again, all 3 are class 1. So I am getting 0 is to 5. Okay, which means if I look at the subset where data is female, I have 5 rows. Okay, and if I make prediction that all 5 rows belong to class 1, all 5 rows belong to class 1. Okay, which means any record that belongs to female, the decision tree will blindly predict it as class 1. Okay, any record that belongs to female gender, decision tree will blindly predict that to be class 1. It's like a rule it will find. That's a rule that decision tree will form based on the class distribution over here. So if that is the rule it is forming, can you tell me what is the accuracy on these 5 records? Accuracy is 100%, isn't it? Or 0% uncertainty. I don't have any uncertainty. I'm certain all the time. All the 5 times I am correct. Correct? Yeah. So decision tree will predict whenever a record belongs to female, that record will be predicted as class 1. And on these particular 5 records, all of them belong to class 1. So I'm having 100% accuracy here. So same thing will happen for male also. All the subsets, the subset that belongs to male, in that there are 5 records and all the 5 records belong to class 0. So by looking at this, majority of the records belong to class 0, right? So decision tree will make a rule that whenever you see a record belonging to male, predict that to be under class 0. As per that, here I will be getting again 100% accuracy. Okay. So initially I had 50% accuracy, like you all know, because 0 is to 1, I had 5 records here, 5 records here. So from 50% accuracy, I jumped to 100% accuracy here and here, and the weighted average, if I get 100% here and 100% here, overall I'll be getting 100%, isn't it? So my accuracy jumped from 50% to 100%, right? And similarly you do for age, maybe you will get, let's say, just for the sake of discussion, you will get 60% accuracy here and 65% accuracy here, and overall accuracy could be around 63 or 62. So yes, so and initially here 50% was the accuracy. Okay, just as an example I'm telling you here. And yes, the accuracy has increased, no doubt about it. But when I divide my data based on gender, that is where the highest increase in accuracy has happened. From 50% it went to 100%. Okay, so in this example, in this data set, gender turns out to be a better criteria to divide the data into subsets. And in this example, country turned out to be a better criteria to divide the data into subsets like this. Similarly, there will be different criteria based on how the data is available with us and how that class distribution is there. Okay, so the major intuition behind the decision tree model is that it will divide the data into subsets. Okay, in the pursuit of increasing accuracy, or reducing the RMSE. If you're dealing with a regression task, reducing the RMSE or reducing the MAE, let's say, any metric that belongs to this. Okay, all right, so reducing the MAE. Okay, so this is the basic intuition about a decision tree model. Okay, and in the next class we will see, I will take an example and we will discuss about what is the formula basically used in decision tree model to find which criteria is best. So over here I have given a simple example that by looking at the accuracies, it will be easy to tell which feature to choose for dividing the data into subsets. But internally, decision tree uses certain formula to find out which feature should be used. There are two major formulas. One is entropy formula and the other one is Gini index. Entropy is based on information gain. Both are like the same thing. Uncertainty reduction is what we look in both the formulas. Okay. Even in fact, you can come up with your own formula if you understand the concept very well. But in the next class, we will see we'll take an example and see how to divide the data and how a decision tree will be constructed from scratch, how a decision tree will be constructed on a given data set using entropy formula and using Gini index. Okay, thank you.